Good morning, everybody. It is 10:10 a.m. I hope everybody can hear me. If you can hear me, say hello on the chat and we'll have a bit of a chat. How has everybody been? Let's have a look who's on. We've got morning Khadija, morning I think that's Dime, morning Tabor, morning Abu. Who else have we got? Morning Sahil. Morning Elsie, morning Dowd, morning, is that Rebecca? Right, okay. Oh, morning Lorenzo. So, it's been a few weeks since, morning Shazabe, since we've seen each other and since we've done a live lesson. Obviously, I hope you've all been really, really well, and I hope that you've all been doing some work. It's been difficult for me to monitor. I, like you, have been confused about what's happening and confused about when we're coming back, if we're coming back, going into school and making classrooms safe, and then coming out of school and being told it's actually something different. So I can understand how lots of you are a bit confused. Morning Fies, morning Yassine, morning Chanel. I can understand why lots of you are probably a bit confused. Morning Charlie, morning Hermione. But we are going to try and get back to as normal as possible with our lessons, our live lessons. And for anybody coming into school, obviously you're going to have a slightly different experience, but you are still going to get lessons. Okay, they probably won't be the same type of lesson. Okay, so before we start, is there anybody who's got any questions that they need answering? Nothing to do with the math lesson, but anything that you kind of want answering, and I can see if I can potentially maybe answer it for you. And then we'll go into our lesson. Morning, whoever Pedro Mendez is. Okay, if you've got a question, ask it in the comment section and we'll go from there. So the book, Khadija, I've already ordered for you and it's actually here in my house now. So as soon as I go back to school, which is next week, I will leave it at reception for you and someone can come and collect it. Or you, alternatively, if you're in school, you can collect it in school. Morning, Bishan. So live lessons, when I'm in school, obviously I can't come online and do a live lesson. What I'm going to do is I'm going to try and do a pre-recorded lesson for you so that you can still have some of the learning that would be happening in school. It will be different because I'm going to try and do it in a stepped order. In school, you are going to be doing specific topics, okay? But I will try and do live lessons every week that I'm not working in school. I will do live lessons, and every week I am working in school, I will be doing pre-recorded lessons. If for some reason I go back to school and I'm back to school every single day, then we'll cross that bridge when we come to it. Abu, school is only open for year 6 reception, nursery and year 1. If you want to come to school, there are set days, so you need to phone the office and ask what those days are, and you need to make sure that that's what it is. Morning, Amani. Okay, right. So I can't see there's any more questions, so we're going to do some algebra today. Algebra is ultimately what a lot of children find the most confusing, but it's not too confusing when you think about it initially as this. So all the way through your school life so far up to year 6, you will have done missing number problems. For instance, such as 1 plus blank equals 3. Okay, and I'm sure all of you here could absolutely answer that question. 1 plus blank equals 3. Okay, and hopefully you have answered that as 1 plus 2 equals 3. So our blank in that situation equals 2. Okay, equals 2. Now in algebra, all it is it changes that blank for a letter or a symbol. Okay, so algebra simply is where we change a unknown quantity for a letter or a symbol. Okay. Now the unknown quantity is the same as your unknown quantity when you was in year 3 of doing 8 minus something equals 2. The something, the blank bit, is the unknown quantity. And in algebra, it simply means replacing that with a letter or a symbol to represent that blank space. Okay. Now, the reason I'm telling you that is because I think quite a lot of people, when they're doing algebra, look at letters and look at numbers and go, I cannot see anything here. But actually, if you imagine that that letter was a nothing, was a blank space, you would be able to understand that all we're doing is replacing the letter, or the number, with a letter or a shape. Now, the reason I'm saying a shape as well is because in year 6 and 7 and 8, lots of algebra comes in the form of what is the value of the shape as opposed to what is the value of x or y or whatever. Okay. So an algebraic rule or an algebraic function, well, again, let's imagine that you are doing 1 plus 2 equals 3. Okay. Now, the function element, the algebraic part, the function element, is the rule is the middle bit, the bit that doesn't change. Okay, the bit that doesn't change. So in science, when we talk about science and we talk about testing, we use a word called variable, and variable means that that amount can change. Okay, so that amount can change. In algebraic terms, that means we have 1, which would be our number that could change. That could be 6, 8, 10, 12. Plus 2 becomes our function, and our answer could also change depending on whatever our first part was. Now that sounds quite complicated, so I'm going to break it down for you so it's really, really simple. So let's imagine a calculation, and our first number in our equation is our input. That's what we put into our machine. Now that can be variable. It doesn't matter what we put into it. It could be 7, 15, 193,726. Whatever the number is, we can put it in. Okay. Now the function is our non-variable bit. Okay. Our non-variable bit. So it doesn't ever change. It's just, this is what it's telling us to do when we put our input in. So we put our input in. The machine says you must do this with the input, and then it gives us our variable output. So our machine says, we program our machine, and we're going to do our machine as it's going to be +1. We're going to put our input of 5. Our machine is programmed to say that our function is +1. Okay. +1. So our function is +1. This never changes. We've programmed the machine to say it never changes, which means our output, which is also variable, becomes 6. 5 plus 1 equals 6. Okay? And when we put that together as a calculation, it looks like this. So we have our input, which is what we put into the machine, our function, which is exactly the same, no matter what, and our output equals 6. Now, so far, obviously, this is pretty simple maths, and it's not that difficult to do, okay? But it allows you to be able to see the parts of a calculation that give us an answer. So our input is our amount we put in. Our function is what we never change, and our output is our variable amount. So you can see from this, if our function is fixed, it doesn't matter what we put into this machine. So we put in 7 and our function is +1. We know that our output would be, show me what it would be, 7, our function is +1, and that gives us the output of well done, 5. It gives us an output of 8. Okay. Now, how this fits with algebra is that we may not know the input and we may not know the output. So let's take this back a step to when we was talking about 1 + 2 = 3. If I was to remove one part of the input or the output, but kept the function the same, okay? So I'm going to make my function +1, and my output is going to be 10. So if my output is 10 and my function is +1, what would my input be? And that could be written as y +1 = 10. Well done, 5, Parisa Tabor. Khadija, Hamayan. It's not 9,999 though, Hamayan. Stush, whoever you are, well done. So we'll move on and we'll have another look at another one. And I know this is probably simple for people, but it's really important that you get this really important fact. Okay, so we've got an input of 12 and our function is +7. Okay, so our output would be 19. Pretty simple. When we put it together, 12 + 7 = 19. Okay, but I now want you to tell me what the output would be if the input was 44. Our function stays the same, so 44 + 7 = y. Well done, Parisa and Faiz. Well done, Hamayan, Ella. Who else we got? I think that's Noreen and Amani and Lorenzo and Khadija and Abu. Yep. So all we're doing at any point is we are keeping our function the same and we are changing inputs or outputs, our variable parts. So how does that affect you when it comes to a question? So here's a question. It says, match the input with the correct output when the output is 14 more than the input. Now, the most important thing here is to read the question. Okay, is to read the question. So it says, match the input with the correct output when the output is 14 more than the input. And the bit we're looking at here is the output is 14 more than the input. So what does, show me in the comment section, what does 14 more mean? What actually does that mean? If we're trying to decide a rule, what would my rule be? What would my function be? Well done, Parisa, Yassine, Abu, Amani, Khadija, Tabor, who else? Hamayan, and Becca. Yep, so our rule would be +14. Now, for the purposes of this lesson, you can see that I've done always the input is green, the rule is going to be red, and the output is going to be blue. So in this case, we know that our rule is always plus 14. Once I've done that, I can then rewrite the calculation using the information I know. So I have 26. My rule is plus 14, which gives me an answer of, what does that give me an answer of? 26 plus 14 gives me an answer of 40. Well done, Amani. Now you know that, I'd like you to have a go at using the rule of plus 14 to find the answer to the other questions. Now, I'd like you to message me them on Class Dojo. So if at this point you're not quite sure, you can rewatch this video and we will look, and you can look at it again and let yourself know how to do this. I'm going to give you a minute to have a look at it and then we'll move on. Okay, so we're going to go through each one. So hopefully you've got a couple of them done. So the next one, we're going to input 7 into our input machine. And we're going to plus 14, which gives us an answer of 21. Then the next one, put our input of 41. We add 14, which gives us an output of 55. And then we use our last one, which is 32. We add 14, which gives us an output of 46. And you can see there that all we've done is exactly what we did in the previous step of using our input, our rule, which we've gathered from the question, and our output, which gives us our second variable. What you can also see from this slide is that actually all of our rule stays exactly the same. So while our variable input and our variable output changes, our rule is consistent. Okay, so we'll look at another one. Now this says match the output with the correct input when the output is double the input. So on the comment section, I'd like you to tell me what you think we should be looking at as our rule. So when the match the output with the correct input when the output is double the input. So what might the rule be? Okay. Right, so this one is a little bit different because actually it's asking us to look at two things. Firstly, it's the rule. To find the rule, we need to look at the output, okay, which is here. And then it says the output is double the input, okay? So it's asking us to find what the rule is between this. And the rule is divide by 2. So our output, we are going to divide by 2 to find our input, okay? So to do that, we're going to start with the output of 32. We'll use our rule, which is divide by 2. And 32 divided by 2 will give us the input of 16. So all we've done is flip around the calculation, okay? The second one, we've got 23, and we're going to divide it by 2. Sorry, 46 divided by 2, which gives us the answer of 23. Then the next one, we have 13 divided by 2, and it gives us the answer of 6.5. Now I'm going to give you a little bit of a tip when either multiplying or dividing odd numbers, okay? Sorry, when dividing odd numbers. If you have an odd number and you're dividing it by 2, okay, and you're not sure how to do it, the easiest way is to either add or subtract 1 and then divide the next part. Now, I'll tell you what I mean by that. So say we have 13, okay? We have 13. If I add 1, it becomes 14. That makes it much easier to divide easily, okay? So that means 14 divided by 2 is 7. However, I've added 1, which means I need to divide that 1 also by 2 and take it off the number, okay? So I have 14, I divide it by 2, which gives me 7, but I've added 1 extra on, so I need to take off half of my 1, okay, which is 0.5, which gives me the answer of 6.5. Alternately, you can take away 1, which gives me 12, and I know 12 divided by 2 is 6, but I now need to add on half of 1. Well, 6 plus 0.5 equals 6.5, okay? Then, the last one, we're going to put our 28 in, divide it by 2, which gives us the answer of 14. Now, in the comment section, which was really interesting, it says double the input. Now, if you would have put, well, the rule is times by 2, that would have also been correct. So 16 multiplied by 2 will give me the output of 32. 23 multiplied by 2 would give me the output of 46. 6.5 times 2 would give me the output of 13. And 14 times 2 would give me the output of 28. Okay? So as long as the consistency is in the function or in the rule, which you can see is there, and the rule works for every single calculation, then if it's the opposite, because all we've done is done the inverse operation here, if you've done the inverse operation and multiplied by 2, the answer would still be correct. Okay. Now, when we see a letter and a number together, or a number and a letter together, such as 2a, it actually just means the letter multiplied by the number. So in this case, it's 2a, and if it was 44a, it would be a times 44, or 9b, it would be 9 times b, or b times 9. Okay. Now, the reason this is important is that actually lots of children, when they are doing algebra, working out algebraic equations, will not multiply, they will add 2. So they'll do 2 add 2 equals 2 add a equals an amount, okay? So it's important that when we're doing this, we recognise that a number and a letter equals the letter times the number, okay? And the letter is our unknown quantity. It's our unknown variable. So in this case, our function is times 2. Our rule is times 2. A can be absolutely anything else. It could be 1, or it could be 1 billion, or it could be 526,926.29421, whatever it is. But the rule would be times 2. Okay. So given that, we now have a rule which is a times 2, and our a now equals 9. So if our a equals 9, what would the answer be? If we were to substitute a with 9, what would the answer be? Well done, Fies. Well done, Tabor. Well done, Lorenzo. Okay, yep, so the answer would be 9 times 2, which equals 18. Now, that's called substitution. We'll be talking about that later in another lesson, because I call it doing an aguero. I don't know if you remember that, but doing an aguero. But what does that look like in the function machine? Okay. We have our input. Well, our input in this case is 9. Our rule is the times 2. And our variable output gives us 18. Okay, so when we break it down into the smaller sections of input, rule, output, we can see that the rule stays the same, but the input and output change. So I have a question, and the question is this. If the input was 41, what would the output be? If the input was 41, what would the output be? So remember before, this would be 2a equals whatever our output would be. Now a in this case is 41. So what would our output be? Well done, Faiz, Khadija, who else we got? Dowd and Ella and Abu and Zuleika and Taba and Amani and Chedza and Parisa. Yeah, so our input would be 41. Our rule would be times 2. And our outputs, not our outputs, that's a completely different thing. Our output would be 82. Okay, great to see lots of people got it there. Right, given that, we now have another number of questions. Okay, and it says calculate the missing outputs when the rule is -8. Okay, now you can see the middle one has been done for you. So we'll look at that one again in a minute. But all we're going to do is rewrite the calculation using our equation. So we have 21 and our rule is -8. 21 minus 8 gives us an answer of 13. The middle one, we have 6 and our -8. Now, if you remember, we have negative numbers. So 6 minus 8, and we can go backwards. And we count through 0. So we go 5, 4, 5, 4, 3, 2, 1, 0, -1, -2. Okay? So we can see it's -2. And then we have 101, and you can do this one. 101 minus 8 gives us an output of, and I'd like to see it on the screen now. So 101 minus 8 gives me what answer? Okay, yep, 101 minus 8 gives me the answer of 93. Well done, everybody who got that. Right, I'm going to give you another minute. There are 3 questions on here, and it says calculate the missing outputs using the rule of +21. So I'm going to leave you to do this one on your own. So I hope you've got your pen, your piece of paper ready, and send me them on Class Dojo. Okay, hopefully you've had a chance to do them. If you are unsure of how to do it, remember you can watch this video again and you can look at exactly how to do this. So we're going to go through this again. So our input is 49 and we're going to use the rule of plus 21. Well, 49, plus 21 that should be, equals 70. Okay, and the next one is 94 plus 21 should be, who can give me the answer in the chat? What's 94 plus 21? Yeah, 94 plus 21, well done. Noreen is 115. And then the last one is 0.25 plus 21. Now, if you didn't know how to do this, if you'd have done place value, wrote them in the place value grid and put 21.00 plus 0.25, that would have given you the answer of 21.25. Now again, even though there's a mistake at the top, you can see that the rule of plus 21 is consistent, but the input and the output are not consistent. They are different every single time. Now the reason for that is if the rule stays the same, it doesn't matter what input I put in or the output that comes out, the rule will be consistent. So if I was to put in the 0.25, it comes out as 21.25. But if I was to put on any number as the input or any number as the output, I would be able to work out either two of the variables. Okay. So look at the next one. I want you to look at this and think of calculating the missing rule. Now, when you first look at a missing rule, it's easy to think, I know this is easy. So we'll look at this together and we'll do 15. So our input is 15 and our output is 5. Now there are lots of things this could be. Remember, it's only one step. So it could be minus 10. So 15 minus 10 equals 5. Now my rule is consistent, so I'm going to try and do the same thing on the next one. So I have 45 and 15, and I put in my minus 10. And when I look at that now, well, 45 minus 10 is definitely not 15. Okay, so that means that rule doesn't work. So then I've got to look at it and think, well, what other rules would work? I'm on 15 and I want to get to 5. So you can tell me what rule, if I'm doing one step, might work if I'm on 15 and I want to get to 5. We tried minus 10, that doesn't work. So what else could work? Well done, Charlie. So divide by 3 might work. So we'll try divide by 3. 15 divided by 3 definitely works. 45 divided by 3, well, let's do it. So 45 divided by 3, 3 goes into 4 once and leaves me 1 remainder. And 3 goes into 15 5 times. So actually, 15 times 3, or 45 divided by 3, equals 15. So 2 work. Okay. Then the next one, we've got 36. And our output is 12. So we can use our 12 times table to see if it goes into 36. So 12, 24, 36, which means our rule is divided by 3. So you can see it may not always be the first one that you notice. So the first one you notice might be 15 take away 10 equals 5, which would be correct for number 1. But the rule for them all is divided by 3. So there's a little bit of trial and error when you're trying to find a rule. And the trial and error could be 1, 2, or 3 different times of you trying something, but the rule must fit every single one of the equations. Okay? If it doesn't, then you need to look at the next rule and look at the next rule. And we talk a lot about working systematically in maths. And systematically means we have a way of working that has a strategy to it. So when I look at this, I think, well, if I'm working systematically, I'm going to start with each of the 4 operations. So I'm going to look at Firstly, addition. Well, if I'm on 15, I'm not going to add anything to get to 5, so it can't be an addition. So look at the next one. Well, subtraction. Well, 15 subtract 10 equals 5. That works, so I'll try the next one. 45 subtract 10 doesn't work, so it's not subtraction. Then I'll look at multiply and think, well, if the number's getting smaller, we're not multiplying. And then I'll look at divide. So you can see I've worked systematically between the 4 operations to find which of the operations it would be, and then the number that relates to that operation. Okay. Okay, it's your turn. This is your work for today from this video. And I want you to have a go, and I want you to send me all of your answers on Class Dojo. If you're struggling to get on your phone or mum's phone or whatever way you can contact me, I'm happy for you to post the answers underneath. If you're not 100% sure of how to do this, then you need to, once this video is finished, is watch the video again, go step by step through everything that we do, and make sure that you're absolutely 100% ready for tomorrow's lesson. Because tomorrow's lesson, we will be doing an Aguero. Charlie, that's your chance to go Aguero over again. Okay? Your questions for today are here. Okay? I want you to thank you for coming online again. If you are owed a book, I will take it into school on Monday, and you will be able to take it home then. Good luck with the questions. Thank you for taking part. I will leave this running for a couple of minutes so that you can write the questions down. I will come back on after that, say goodbye, and then I will see you all tomorrow. Okay, hopefully you've managed to get them down. If not, you can rewind the video in a few minutes when it's uploaded, and you can have a look again at the lesson. Have a wonderful day, everybody. I hope you manage to get outside before it rains and the heavens open. I will see you again tomorrow at 10 a.m. So have a great day. Try and do some work, try and do some exercise, and have some fun with your family. Take care, everybody.